All right, welcome to the third and final video for nonlinear optimization. This is another Markowitz portfolio problem. I actually prefer this setup a lot better than the one that's in your book. So once again, we've got a series of investments. Here I've just called them X, Y, and Z. The idea is to determine what percent of my available funds I should invest in X, Y, and Z. I've got two choices. Just like the book, I can maximize my expected return subject to some level of risk, or I can minimize my risk subject to some level of returns. So we'll do both of those. The key difference here is the variance of the portfolio. And the reason I wanted to show you guys this is because I'm under the impression that this is actually how financial planners calculate the variance of a portfolio. Talking to Harry, you guys get these expected returns, but you guys also get the variance for the various returns and then how they co-vary between themselves, right? And so this formula here should look familiar to you. So if I'm just going to invest in, investment X and Y, well then what's the variance of that portfolio? In other words, what's the variance of X plus Y? Well, it would be the variance of X plus the variance of Y plus 2 times the covariance between X and Y, all right? So what I've done here, now that's a formula I hope everyone has seen before. If not, we can talk about it in class. And then I want to do a quick add-on. So, what are all these A's? What's the A and the B? Well, in this problem, right, our investment in X is going to be weighted by what percent of our funds are invested in X. Well, that's A, right? B is what percent of our funds are going to be invested in Y, right? Because, I may not invest all of my funds in X or Y. As a result, I basically need a weighted average of the variance between X and Y, right? So to do that, that variance is this formula here. I now have A squared times the variance of X, B squared times the variance of Y, plus 2 times A times B times the covariance, all right? And for those of you that have a bit of a statistical background, right, the idea here is that I can take out the A and the B from the variance formula, but whenever you do, you have to square that A and B because your variance is squared. And then what's happening here on the covariance is I am taking the A and B out of the covariance, but covariance is not squared, so I don't need to square the A and the B. And then finally, I wanted to show you this. This is the actual variance formula for our problem, right? Because here I've now added investment Z. So again, A is going to be the percent invested in A, B invested in Y, C invested in Z. So I need to take a weighted average of my variances. So again, I'm going to get A squared variance of X, B squared variance of Y, C squared variance of Z. And then I wanted to point out here, because it's hard to see this in this formula, but whenever you take the variance of, say, 3 or more variables, you always have to include the covariance between all of the variables. And so that's what I'm trying to show you here, right? Here is the covariance between X and Y. Here's the covariance between X and Z. And then finally, I have the covariance between Y and Z. See here, you don't really see that here because you just have the covariance between X and Y. So there's just one covariance, right? But anytime you get 3 or more variables, you have to calculate the covariance between all combinations all combinations of your 3 variables. All right. And then of course, if you wanted to expand this to another investment, you would have, I guess X, Y, Z, say double X, right? Then the number of covariances you would have to calculate is going to grow exponentially because now I need the covariance between X, Y, xz, x double x. And then I need the covariance between y and z, y and double x. And then I need the covariance between z and double x, right? So the number of covariances just grows and grows and grows. All right, so bottom line, in this formulation of the Markowitz model, this is our covariance. So this is our risk factor, all right? Well, what we have to do now is calculate this in Excel. And it turns out it's really easy. So the first thing I want to do is here, I want to set, I need my choice variables, right? Because this is the A, the B, and the C. And so what I'm going to need to do is I'm going to put something in here. So 0.33, 0.33, 0.33. Okay? So I, assume I'm just going to put 1/3 into all these investments. All right. Then we can do this in 2 steps. So this first one I'll call like an intermediate step. Intermediate step. All right. So this is just going to be the simple sum product. So I'm going to take the sum product of this column with the sum product of this column. All right. But let me do it first and I'll show you what I'm getting at, or show you what I'm doing. So sum product of this column and this column, okay? And then I want to anchor my weights, okay? And then I want to pull these all over. Make sure I got it. Yeah. Oh, boy, that was foolish. I anchored the wrong thing. Got to anchor the letters, not the numbers, because I am copying across. There we go. Okay, so what we have here in this sum product, right, I have A times the variance of x, A times the covariance of x and y, A times the covariance of x and z. So if I look down here, I have A times the variance of x, and then I have A times the covariance of x and y, and then A times the covariance of x and z, all right? And then of course here, I have the covariance, or so I have A times the covariance of x and y, that's what this is, and then, oh, I'm sorry, this is B. Actually, I said that wrong, right? Oops, let me get out of here. Right, I'm sorry, I have B, I'm sorry, dang it, I have A times the variance of x, B times the covariance of x and y, C times the covariance of x and z, right? So I've got part of this, and part of this, right? And then y, or in this one, I have A times the covariance of x, y, and x, so that's right here. B times the variance of y, that's one of these. And then C times the covariance of y and z, so that's one of these, okay? And then you have the same thing here, right? A times the covariance of z and x, right here, one of these. B times the covariance of z and y, that's this guy right here. And then I have C times the variance of z, that's one of these. Well, then what you can do, so I get this intermediate step, now watch, then what I do is now I'm in a position to calculate my variance. And your variance, and hopefully you guys see this, is simply this row times your intermediate step, and voila, right? Because now I'm taking, again, A, B, and C, and I'm multiplying by all of these that already have A, B, and C times their variances times their covariances, and then summing everything together. So actually this is my variance, all right? Now, if you don't see that right away, it's not an issue because you can always do this manually, if you will. We've already got the variance of A, right? And so I could just take that by A squared. So here I could just simply take, to show you, my point is to show you that this is right, I'll actually calculate this formula doing it the long way. So here I'll take this number squared, right? And then multiply it by the variance of x. So that'll be my first term. And then I'm going to do the b squared. So b squared times the variance of y. That was this number. And then I got my c squared, so I could just do this. I got to do this. That squared times the variance of z. That would be this number. And then I'll do my covariances underneath it. So here I have 2 times a times b times the covariance of x and y. That's just this number. And then here I have 2 times a times c times the covariance of x and z. That's this number. And then finally, I have 2 times b times c times the covariance of y and z. That's this. And then lastly, I just have to add everything up. So if I sum all of these, voila, I get the same number. All right, so that's what I was trying to get at. Now listen, if you feel really comfortable in Excel, I would recommend that you just do this intermediate step, right? And then finally, just do this last sum product. Now, if this, if you don't feel comfortable with this or it doesn't make sense, fair enough. Then just calculate your variance the way I did it here. Literally, just take a squared times the variance of x, b squared times the variance of y, pardon me, so on and so forth, and you're going to get the same number, all right? So there is our variance. So I'm going to use this one. And then the last thing I need to do is my expected return, all right? And so I'm going to put that up here, expected return, okay? And of course, my expected return is, it's a weighted average of how much I invest in each investment times their expected returns. So this one is just another sum product, right, of what I'm going to invest in times their various returns, and then presto, all right? And then lastly, to tell you what, my apologies, let me move this down 1, because the last thing I need to do, right, whenever I'm dealing with these percentages, I always need these percentages to sum to 1. We've dealt with that in the past. So let me do that real quick. So sum, okay, there. Oops, I didn't need to do that. And then, of course, this has to equal 1. All right. Now, I did not put anything, constraints yet on my expected return or on my variance. Now, the reason for that is because, as in the other model, I can maximize my expected return subject to some variance or minimize my variance subject to some expected return, okay? So let's maximize my return. So if I'm going to maximize my return, then I want my variance to be less than or equal, I'll just put in 0.03, okay? So what I'm trying to point out is if I'm going to maximize my return, then I have this constraint and this constraint, all right? Now, in a minute, I'm going to maximize my I'm going to minimize my variance. So when I minimize my variance, I'm going to have this constraint, and then I need to put a constraint in for the expected return. All right, so let's maximize the expected return. So I'm going to go into Data, Solver. Okay, so I want to maximize my expected return by changing these three cells, right? And subject to this has to equal 1, so it has to equal 1. And then my variance has to be less than or equal to some number. And again, this is something where, you know, you're talking to the client, how much risk do you want to take, you know, so on and so forth, or you maybe have a way to figure out what the risk tolerance is for your client. But that's what you would plug in here. I hit OK. I have my non-negativity constraints. This is a nonlinear problem. So I hit solve. I get an answer. Yay for me. So what I'm going to do here is, under this problem, I'm going to invest 39% in X, 47% in Y, 15% in Z, and I'm going to get an expected return, right, of 17%. And by gosh, I will be minimizing my variance, right? I'm going to have a 0.03 variance of my entire portfolio, all right? So the other way I can do this is to minimize the variance subject to some return, subject to a return. But in this case, you always want the return to be greater than or equal to some number. So this case, I've got a greater than or equal to here. And let's put in 0.15, all right? So now, that's the only change I have to make. Now I go back into Solver. Everything else is basically the same, right? But now I want to minimize this cell. I want to minimize my variance. I want to change the same three cells. I still want this constraint to equal 1, right? The sum of my investments must equal 1. But now you need to get rid of this constraint, and now you need to add this constraint. So that has to be greater than or equal to that. Hit OK, non-negativity, non-linear, solve, another solution. So here, right, in order to get, to minimize this variance, I've got my smallest variance. I'm going, so notice here my variance actually went down. Now, of course, my return did too. But if I minimize, what's the smallest variance I can get out of this portfolio? It's about 0.02, right? But thankfully, I can still get at least a 15% return, all right? So in this case, obviously my investments are going to change. Now I'm going to put 52% into X, 37% Y, 12% investment Z, and I'll get a 15% expected return, but my variance is only going to be 0.02. All right, so there you go. Another version of the Markowitz model. You know, I know I've already said this, so I apologize for repeating myself, but I think this is a much better model than the model that was in your book. Again, I really think this is the way most of those software packages that financial planners use. I think this is what they're doing. You know, you're getting expected returns for these various investments. You're getting variances and covariances for all of these investments, right? And this is how you would calculate your expected return and your variance for all these investments. Now, I confess, and the reason we use software is because even if you try to do this in Excel, as you start to add more and more investments, right, this variance formula, it grows exponentially, right? So not something, ideally you don't want to do this in Excel if you're picking between 15 and 20 investments, right? That's a huge variance formula. And that's why we use these other software programs. All right, well, at any rate, that is enough. So this, despite the fact that this problem is not in your book, you will be responsible for it. This will be, you know, on the homework, can potentially be on your midterm. All right, so that's it. That's it for Chapter 8, Nonlinear Programming.